Welcome to Radio Fixer's channel. Subscribe for upcoming videos. Not sure if this radio is fixable since it was damaged in an electrical fire. But you know me, I don't give up that easy, right? I actually enjoyed the challenge, believe it or not. So stay tuned to see if this restoration is possible or not. Let's get started. Already my goal is to create these videos so a brand new person can use the information and be able to get into the hobby. It is really a wonderful hobby and very rewarding to bring back something that totally dead back to life and sing again. And this is my first AC/DC portable battery operated radio that I will be working on. Here is what this radio will need. Test all coils, the speaker, IF and RF transformers, and other components to make sure they're all okay. Test all wiring since much of it was caught in damage in the fire. Remove and test all tubes to see if they're okay or not. Identify and replace all paper capacitors. Repair the multi-section electrolytic capacitor that is very hard to get to since there is not enough space. Test and replace all bad resistors. Replace the selenium rectifier with the high voltage diode and also high watts resistor. Replace the line cord with a polarized cord, of course. Repair the cabinet. It's in bad shape. Hopefully it's repairable. Create knob for the radio. Also create a center logo for the radio. I need to check online to see if I can find something to see what I need to do. Of course, many other things as expected, right? Whenever you work in this type of project, you don't know until you get to it. Alright, let's take this thing apart. Already took all the tubes out, so let's take the speaker out, be able to get to this box. It's about 3 screws to remove the speaker. That's the only way you can get here. I couldn't take these tubes out until this be removed. Okay, now I can get to the tube. As you see, it's rust out totally. There's a lot of rust that I need to take care of it. This is for those of you who just got started and feel uncomfortable reading a schematic. And that is very normal. It will take time to get comfortable to read the schematic. Hopefully through this video I can show you step by step to do this and also be able to read the schematic. First, what I do, I draw. I draw this, like where the speaker is, where this cap is, When you remove the tube, check it out and mark them. Because later on, you need to know the tube location. Alright, so like I put here, the switch is right here. This is on and off switch. As you see, I have it here as well. Then I turn this around and look under the chassis and I start marking the pins for each tube. See, because when I do this, it's exactly like that, right? You see what I'm talking about? Always the marking the pins is clockwise, 1 through 7. Some radio, they might go up to 8 or so. So each of them, they're different. You see, you look at the layout. See, the space between this tube, they call it key. So it starts 1, goes through 7. Hopefully that makes sense. See, the space goes clockwise. So I put all other parts as I see under the chassis. I draw it here as well. Why I'm doing this, when I start removing capacitor or any parts, I draw it here. So later on I can follow through this. Believe me, if you haven't done this, you want to take this process to make your job easier. Otherwise, you get so confused. Even I take bunch of pictures, I also draw like this. Then I make bunch of prints like that. That's much easier. Of course, you will see I draw like this, but I'm doing this for a while. So don't do it this way in the beginning until you get more comfortable with it. Let me show you what I mean. Take a detailed note when you're removing, wires. For tubes or anything else under the chassis, make sure to take a good note. Since a schematic, for those of you who just got started, is hard to read, even myself, it took me a long time to get comfortable with. The way I get comfortable with the schematic, I actually look to see where the wire goes under the chassis, then I try to find that on a schematic. That's the way you start getting comfortable reading a schematic. As you know, a schematic layout is not this way, all right? It's a totally different way. Let me show you what I meant by when you look at the schematic, it's a little different than what you're actually seeing. Let me explain that. This is a schematic for this radio that I'm working on. Of course, when you look at through a schematic, if the line goes across like here, up here, you see there is no soldering. They're not connected to anything here. If you see a dot like that, that means the area was soldered. You see, this is all the solder area. But again, if the line goes across like this, there is no connection. Okay, with this radio that I'm working on, this is the power plug, of course. One side of it, is soldered to rectifier, is a selenium rectifier. Then from there, it comes to a resistor. That's a 47 ohm resistor. That's a 1 watt. Then if you continue, it comes soldered to another resistor. This is a 2 watt resistor, and that's a 250 ohm. If you continue from here, it comes all the way, is soldered to this section of multi-section capacitor. That's a 40 watt section. For example, this has 3 wires connected to this pen of multi-section capacitor. I draw that on this page by itself. So what you do, which I will show you later, you put your multimeter in this pen, then you will try to find where that wire goes. As soon as you find it, then draw it on the paper. Same thing here. Another example I give you, this is, where all the grounds, it has 4 different grounds, 3 of them, there's a bunch of wires connected to it. I'm going to focus, just draw one side only. I'm going to do one by one. Do not do multiple of them like what I did until you get comfortable with it. So you see what I did, right? Again, use multimeter, make sure all the connections right before you put it here on the paper. Because after you're disconnecting, you have nothing else to go with. And taking pictures is a good idea, but sometimes picture is not as clear as you actually draw it yourself. Hopefully this will help you. It really helped me a lot. All right, let's pursue. See, I already draw this first page, first layer, I call it. What that means, capacitors that actually they're in the surface, the one that I can remove first before getting underneath. Because some of them, they are like a layer, under each other. I cannot remove all of them. I have to do the top first. So I draw exactly where those capacitor is. Like this one is a pin 6, and this side is hooked up to the center of the volume control. Let me show you. This is the one. You see that? Pin 6, and also hooked up to the center right here. Sometimes, you might break those pins. So the easier way is not to remove them. Just cut them somewhere. Give enough space here that you can solder the other one right here. If you feel comfortable to remove it from here, feel free to do that, but there are more wires there. I don't want to mess around with that. Hopefully that makes sense. Let me cut it. You see, I cut right here. I left this side up so I don't cut other wire by mistake. Just want to cut one wire only, okay? And then I can remove it. Be very gentle with it. See? It's out. Now let's clean this to see what type of capacitor it is so I can put it in my drawing. There's a couple of ways you can do that. One, just use something and remove the wax, but be careful you don't mess up the paper. You can get a lighter like this, just heat it up because it's a wax. Then quickly clean it. Be very gentle with it. Okay, now I can actually read it under magnifying glass. That's the 0.01 microfarad, 200 volts. See, now we know what that capacitor size is. As you see, I did the same thing in all of them. Alright, so when I talk about layer, that's what I mean. You start from the top, gradually goes low. So then I'll finish with this. I'm going to put it aside. This is page 2, and I already removed this. I haven't removed this yet. This is the second layer. What I mean by that, after removing that, now I can remove this one and I can remove that one. Alright, I have not removed this one yet. As you see, I already have it. I already know where it hooked up. This one is hooked up to the ground. None of this pin. Right here, there was solder right here. So again, you want to make sure you draw this correctly before removing them, because if you draw it incorrectly, believe me, it's not gonna work, right? These are actually, you know, the capacitor. This is a positive, all these are positive. These are the ground or negative side of capacitors. Always mark all this. And later on, I think it's going to be much simpler to put it back together. Believe me, it's going to be much simpler. So what I do, I look under the chassis where this multi-section capacitor is located. I look through every wire. See one right here? This wire comes connect to here. So I draw that right here. You see that? Then I also test it to make sure that I am picking the right wire. Very simple. I hook this up right here, then here. So that is the correct wire. It goes from here to here. So the third layer, that's what I'm doing. Going wire by wire. Draw it here, then test it to see if I picked the right wire or not. Hopefully that makes sense. Alright? Again, the purpose I'm doing this to make my job easier. You know, do layer and layer. That's going to make the job much easier. Alright, finally I removed this. It took forever to take it out. Of course, this is aluminum capacitor, was inside this canister, like a paper canister. Tons of tar that I have to remove it and clean this. So let's test this according to what it says right here. You see there's the symbols. The symbols are very hard to see. Like if I show you right here, you see this is a square. This is triangle. You see that? Triangle. And this is nothing here. This one should be 100 microfarad and 10 volts only, 10 volts. This is half moon or half circle. So let's use this equipment to test it. We're going to put one side and the ground, you know, with the body, that's where the ground is. If we look at here, so half moon is 40 microfarad, 150 volts. So let's start half moon. This is a picofarad, it's 138 picofarad. That's a very small reading. This is supposed to be 40 microfarad. Very bad. Very off. I mean, very, very off. Let's test the circle. And the circle should be 30 microfarad. It shows 116 picofarad. Very off. Bad capacitor. So let's test this one, which is triangle. Okay, the triangle, it should be 20 microfarad. See that? It read 22 picofarad, not microfarad. So anyway, you see how bad this capacitor is. I need the space. I'm going to cut this, and install new capacitor inside here. I made a video how to do that. I'm going to put the picture up here. I suggest pretty highly to view that. That's walk you through step by step how I open this up, what type of process I used to rebuild this. All right, hopefully that video is going to help you. So let me work on this and get back with you. See, this is already start rusting out. I try to clean it and it's not cleaning up. So it's definitely is rust. I'm going to remove this, then put it in some type of chemical. I'm going to put a picture of what I'm using up here so you know what to look for. This is a great product I'm using for a while. It has a great result. I highly suggest to use it to get rid of the rust. So let me take it out. This is very simple here. There's a little pen. See right here, this pen. By removing that, that will come out. But first I'm going to release this string, goes around it, so be able to remove it, all right? I'm going to try to do as simple as possible, so later on I can put it on easier. See this little pen? I'm going to put my finger here so it doesn't pop out. It's a lucky locking pen, that's all it is. You see this type of locking pen. This was looped one time all around here, then it went to top here. I'm really videoing this for myself, so later on I know how to put it back together. There's a spring right here. I'm going to remove that. Sitting right here. See, like that. Later on I can reinstall this. This is the second one. This one has two. One is here. Another was back there, as you see. So we remove the second one. The first one is fine. Alright, it's out. Let me go soak it, leave it there for a few hours. Alright, the rust is removed totally, it's painted. It looks just like a brand new. Again, I'm going to add all the product I'm using in the description section of this video. Feel free to check it out. Alright, so let's install this. It goes right here. I'm going to install this before put the capacitor back. It's going to be much easier to do it that way. But before we do that, I must just wrap it around here to make my job easier. Let's see if that's a good idea or not. Alright, this is back. It was a little challenging because it has two strings, one for this wheel. Then in the back, there's another one goes here. So they all need to be synchronized to be able to work both. Alright, that is done. One thing I suggest to do, clean all the LEDs before you install it. Alright? See, I already run all the four capacitors already inside, already run the wires, everything ready to be installed. And I marked here, that goes in the front, there's another mark here so I know where they go. So let's install it. See if it. I'm just going to twist one of them instead all four. No wire was soldered to it, so this is the only one I'm going to bend a little bit, be able to hold the capacitor in place so I can start soldering them. So just go right here. See, now it holds there. Just bend it a little. You don't need to do it too much. So if you plan to take it out again, it's going to be much easier. If you bend it too much, it's going to be much harder to remove it. Now to start soldering everything back together. Alright, all those wires that I remove in the third layer need to be hooked back to these capacitors. So we're going to start from page 3 or layer 3. You see all these wires? I'm going to hook them up. I'm not going to solder them. Why? Because some capacitor, if you look at page 2, some capacitor also need to be connected to some of those. If I solder them, then adding those capacitors is going to be challenging. Hopefully it makes sense. I'm going to go through all this page by page to see what I need to solder, to that multi-section capacitors. Hopefully this makes sense. So I'm going to start this one first, all right? That's why I draw this, so I know all those wires where it needs to be connected. Hopefully that makes sense. One thing I want to share with you that is very important. We all know we need to replace all the old capacitors. Paper capacitor, multi-section capacitor, these are sometimes over 30, 40, 50 years old. It's best you change them. Don't try to reform them or anything like that because they're pretty old. But my understanding is they're going to go bad soon. Believe me, they goes back soon. Also, what you want to do, you want to check the resistor around the power source. Majority of the resistors close to power source, make sure to check it. Of course, I will check all the resistors here to make sure they're all fine, but let me show you the reading of this one. It's a brown, black, blue. I'm going to key that into the database that I designed to make my job easier. And since I don't want to do a lot of calculation, try to look a lot of chart. Again, hopefully this database is going to be available soon that I can offer to everybody who need it. I call it classic resistor. So the colors was brown. You see popped up here. So be easier to read. Black and blue. Usually resistor, they have 3 colors, in the end. Sometimes they're gold, sometimes they're silver, but this one that I'm working on has no color, so that's selected. That's a 20% resistor. Here it shows this resistor should be 10 mega ohm, as you see right here. The minimum that acceptable is 8 mega ohm. The maximum, it should be 12 mega ohm. So we're going to compare this to the resistor that I have. Let's see what type of result you're getting using multimeter to test that resistor. Just want to show you how close these two multimeters are when I'm measuring the resistor here. As you see, this is pretty close. Of course, this is very expensive one. This is more reasonable. This is about $30 and it's doing a very good job, as you can see. The only thing you need to know about this, when you hook it up, just wait a second. This one show immediately the reading. This goes through a little bit. Wait a couple of seconds, then you will see the accurate reading. I put this, of course, on the hold, to be able to show you. If you haven't watched the video I made about this multimeter, definitely take your time to watch it. I'm going to put here a picture of it. It really is doing a good job for me. And again, the difference is price-wise. Just again, when you hook this up to resistor, capacitors, anything like that, it takes a few seconds to show you the accurate numbers. Just want to show you how close they are. Okay, I found the resistor I have. Let's test this. This is the new resistor that I'm going to replace the first one with. Wait until it shows you the correct number, because what it does is automatically try to read the resistor. This is a 10 meg, that's of course is ohm, these resistors, so that is what I need to replace the first one. So we're going to test this one right here. So this is the one where the capacitor actually caught in fire. Let's just see it. Again, when you hook this up, wait a few seconds. It shows 11K. Alright, let's key the second resistor. Again, is a classic. The colors was brown, black, and red. Of course, in the end, there's no color, so we're going to select no color. So here it shows this resistor should be 1K, 1000 ohm. The minimum should be about 800 ohm. The maximum about 1.2K ohm. As you see, our resistor is way off. I mean, that is a lot. That is just awful number, you know. Now you know why you need to test your resistors. Look how off it is. As you saw, when we key those, you know, colors into the database, it shows 1000 ohm. This is 11,000 ohm. That is why you have to test every resistor, especially the one around the power source. I know I keep talking about it, but I want to show you, you know, how off this is. All right? So we're going to find another resistor. We're going to replace that as well. And this is a resistor, of course, we're going to remove. As you saw in the video earlier, that's supposed to be 10 meg. Of course, that was way off. Of course, here I put a note for myself. It said this is a capacitor. That's on page 1. That's where I need to look at to see what's connected here. And here it says there's another capacitor hooked up to that pan. That is a page 2. Again, that means the layers. This is the first one I took. That's the second layer that I took out. So take a good note to be able to put this thing together without that much issue and challenge. So this is what we test, and this is what we want to replace. All right. Again, the reason I'm showing you all this is again all this video I make for the new person, so they don't feel overwhelmed and be able to perform and enjoy the hobby. It's just a great hobby, you know, for those of you close to retirement or thinking of to do something else to be fun. I suggest pretty highly, you know, to pick this hobby because it brings a lot of personal satisfaction, especially when you bring something that totally dead back to life. Alright, let me show you those two resistor location or schematic. Okay, here the blue line, it shows the B minus. You see it start right here from power side. It goes all the way here to volume control and of course continue. But I'm going to show you just a resistor how I hooked up to this line. This is that 1K or 1000 ohm resistor that I shared with you. It hooked up to the pin number 5 on 3V4. And if you see it continue, it's soldered right here to that line, the B minus. The other resistor, the 10 mega ohm resistor, is one side is soldered to pin 6 of 1U5. If you continue, you know, it comes down and also soldered right here to the same B minus. Of course, this side of B minus is hooked up to here. This is a volume control. Usually volume control, that's how they show it. The one thing again I suggest, when you work on the radio to get comfortable with the schematic, try to find those parts on the schematic and do the drawing like I did. Then gradually you start getting familiar how to read the schematic. Hopefully this can help you. All right. Let's remove that resistor. One thing I highly suggest to do When you're removing parts from the chassis, add some new solder to the part where it was soldered. The other solder will melt much quicker and it will come out much simpler. Especially with two pens, be very careful not to break them when you unsolder parts from them. So add some time to the soldering gun. Now I can remove it much simpler. Let's see, it's melted right away. Otherwise, it takes forever. As you recall, two of this capacitor was resistor was across of them. So I have to create two of those capacitors, which was 0.05 microfarad. Okay, let's use this calculator to see what type of compatible capacitor I can use, the new capacitors. Sometimes they call them yellow jacket. So we're going to select this compatible capacitor. This is 0.05. The good thing about this calculator, it tells me what type of part number I need for the new capacitor. That's this film capacitor. The part number is 503. Here I can change the tolerance. Of course, the old capacitor was about 20%. So in the bottom, it tells me the capacitor that I select was 0.05. The minimum value in that capacitor is 0.04. The maximum value was 0.06. Of course, when we measured those two capacitors, since they were in very bad condition, the capacitor tester could not even read it since they were pretty bad. The good thing about this calculator, as I mentioned earlier, it will tell me immediately what part number I need. That makes my job much easier, to select the proper capacitor to install. One thing I suggest pretty highly, always test your new part before installing them. Resistor, capacitor, sometimes manufacturers, when they create this, once in a while you're going to come across the bad one. So you don't want to install it, then later on you realize it was not a good capacitor or resistor. So always check it, always. Both of this capacitor is 0.05 microfarad, and one of them it has 1K resistor, other one is a different size. So this is a 1K resistor for our first capacitor. See, I put it right on top. I twist it right around, exactly like the way it was. Alright, both sides is soldered. See, that's how it look like. So now let's install this. Sometimes this is the method I use, especially when I can't get to the part or it's so hard to remove the original part. I usually cut the part out and make this, I believe they call it pigtail. Then I can install this right over the leftover of the wires from the old part, then solder it. Let's see if I can show you what I mean by that. Okay, this is a good example. You see that right there? When I cut the part, I left some wires here. See, there's an extra wire from both sides. See, it's right there. Both sides, I left some wires from the old one. So that part I'm going to put over here, then solder right here. So I don't need to remove all those wires and parts out of this pen. Especially sometimes it's so hard to get to the pen, and you have to be very careful not to break these two pens. So that's the simplest way. If there's too many parts soldered to it, do it this way. Cut the old part, leave some wire from the old part, then you can install the next one here, the capacitor that I just made, then solder right here. One thing I suggest to do when you hook every wires, put a check mark here that this is already been taken care of. Of course, since all of them now is hooked up, include this capacitor, if it was on page 2, hooked up to this pen, now I can solder all of them at the same time. As you recall, The positive or the hot side of the power cord was soldered right here. From here, if you continue, it goes to this box here, which this is what I'm thinking is selenium rectifier. Of course, we're going to open it up and check it out, because the schematic shows is the selenium rectifier. Then from there, it comes right here. There's a resistor. You see that? That's a wire wound resistor, some type of resistor I never saw before. It's like this, it's like this. This is a resistor as well, but it's much smaller. That's a 47 ohm resistor. You see, it's soldered to one of the pin in this tube, but the schematic does not show that it's soldered to the tube. That's what I was talking about. You know, that is a little different. They solder that resistor to that pin of that tube. Then this resistor, the next resistor, larger resistor, also solder to that. So that is how they connect them together. So if you continue right here, is soldered to this resistor, this large resistor. You see that? Then from here is soldered to other resistor. This resistor actually goes all the way. If you continue, the wire is hooked up somewhere right there. This is the switch. You can select to run this radio on electricity or the battery. So that is where it's hooked up right there. This side of this resistor, this large resistor, also there's another one. That is where the 330 is hooked up to the B minus. You see, B minus is right there. I know a little confusing for those of you just got started, but again, go wire by wire, try to find it and look at it in the schematic. Then pretty soon you start getting more comfortable with a schematic. Hopefully all this video is helping you. As you notice, all the capacitors are installed, as well as the bad resistor was replaced. Here I choose to install 2 watt resistor instead of what they had. It was one of those small resistor. Of course, I kept the same value. It's a 1000 ohm, but it's a 2 watts because it's close to the output tube 3Y4. Let me show you a schematic. You see, this is it right here. It's the output 3V4, and this resistor I install, as I mentioned, 2 watt resistor. And the only thing left, this capacitor 0.05, I'm going to use here a safety capacitor. Let me show you why. Why I want to use safety capacitor, as I mentioned. And this is it. This is right here. This is a plug, of course. As you see, one side of the plug is hooked up to this capacitor 0.05. The other side, this capacitor is soldered right to B minus. So this is where I'm going to use safety capacitor. My understanding is Y2 safety capacitor can be used right here instead of regular capacitor. I will stop the video here since it is already getting long. Really, the big question is, can this radio be repaired after the electrical fire? I wouldn't know for sure until I replace all affected components. What do you think? Let me know in the comment section. So stay tuned for the next video. I'll be honest with you, it takes so much time to make these videos, editing, uploading, and make sure there's enough information that it actually makes sense, if you want to follow. At this time, I want to take the opportunity and thank my subscribers with their uplifting comments. You always encourage me to upload more videos, since this is just a hobby of mine. Again, I appreciate you. Enjoy all these videos, and you all have an awesome day. Take care. If you're interested to see more videos like this, feel free to subscribe to my channel, and you will be notified when a new video being uploaded. You have a great day.